Okay, so I've been asked to set the scene, if you like, to give you a very quick overview of where we currently are in terms of climate change, carbon emissions, and a little bit of analysis of where the carbon is in infrastructure. So I'm going to be very brief, and forgive me if you may well know some of this already. But it is important in terms of setting the scene. So when we think about global carbon emissions, you're probably used to seeing these figures or this graph. So the most important points to take from both these graphs, one is looking at total greenhouse gas emissions, and that includes land use changes, so things like deforestation and fires, etc., which contribute to greenhouse gas emissions. But if you take that away and you just look at carbon dioxide levels and emissions, you'll see that emissions are going up almost in every situation, every country. And they're going up fastest in developing countries, so India, China, for example. So that's nothing new. But I guess what we do need to understand is that's not a good situation. You know, regardless of where we are, we need to change that. The current situation and using the most available data actually doesn't give us much hope at the moment, because in the last year, so looking at the 2017 data, our greenhouse gas emissions globally actually grew by roughly 3.5%. And that came after almost a slowing down for 3 years, where we thought actually maybe we've got a chance that we're managing it, but suddenly it popped up again. So we've got to be very careful about this. So I don't know if any of you know, but the CO2 concentrations in our atmosphere today have reached their highest ever level. It's something like 411 parts per million, or at least it was on Sunday. That's the highest for 800,000 years. March of this year was the 5th warmest since 1880, and we've got consistent records of the hottest year being more and more common. So that's the background for today. We've got this situation, and you think, well, okay, so I'm in Europe, I'm in Sweden, we're managing it. Okay, well, actually, we have to be careful, because the impacts of climate change affect us all. So we are part of a global community that needs to take action. And that action is happening, and today is part of it. But scientists have looked at where we're going and what the potential scenarios are. So this graph gives you that information. And on our current projections, we're going to have at least a 3-degree warming of our global atmosphere, potentially higher. 3 degrees or more gives us catastrophic climate change, the impacts which you're probably quite well aware of, drought, heat stresses, more disease, flash flooding, sea level rises, oceanic islands disappearing, etc. So the Paris Agreement 2015, which was signed by the leading nations, is committing to try and restrict that global temperature rise to 1.5 or 2 degrees. And that takes us into this territory of actually having to take carbon out of the system faster than we're putting carbon into our atmosphere, the so-called net negative scenario. And the scientists have worked out what the emissions gap is. So the business as usual going to 3 degrees or more, and where we need to go to get carbon out of our system. And we're looking at a reduction of between 14 to 19 gigatons of CO2 equivalent per year. So we need to get into that net negative global emissions. So that's a big challenge that we've all got to face. And I thoroughly recommend reading this report. It gives you all the most up-to-date science, and it was published in the end of last year. So that's a little bit about the challenge. And then you say, well, where is the carbon? And funny enough, when you talk to city officials and governments, not everybody knows. But this is some approximate data. So when you look at global energy and process emissions, and you look at industry and buildings, and for buildings it's probably closer to 40% here. So this pie chart on to your left. And then you start to see, well, okay, you break it down. So in industry, where is the carbon in infrastructure? Well, is it in steel? Is it in cement? Is it in aluminium? Would it be in glass? And the global construction value is estimated, this is globally, yeah, is estimated to influence over 20% of our total CO2 emissions. So it's not an insignificant part, a fifth. And if you look more closely at the detail, and this is drilling down into some Swedish data, you'll see that you've actually got good exposure to understanding of where the carbon or the major sources of greenhouse gas emissions are in your infrastructure project. And it's no surprise, concrete, reinforced steel, asphalt. And hopefully throughout the course of today, you'll get an understanding of what your sector, what businesses are doing to try and reduce these elements, reduce the carbon intensity in some of these materials. And so what that leads us to, or at least leads me to conclude, because this is just the tip of the iceberg in terms of a presentation, the detail is going to come more through the next lectures. I think we all agree we need faster and deeper cuts, yes? And we need this in infrastructure as well. And what does that mean? Well, for me, it means we need to rethink our systems. It means we need to have new approaches to design. And in some cases, you may hear about it today, that we may not even think about the need for that infrastructure. Do we actually need to build? Is there something else that we could do? Can we be more clever? We need more different ways and different approaches around our engineering processes. We need to obviously reduce the carbon in our most intensive materials. And how do we do that? Better design, through the use of substitution or innovation in terms of material science. How do we reduce the emissions associated with the transportation of materials, because that's also significant and important. And then when we go through and how we've designed it and it's delivering, how do we improve the carbon efficiency in the actual life of that building or that infrastructure in terms of operation and maintenance? So we need to do this. And with a population that we have around Europe, maybe aging, could be growing, we're going to need more infrastructure to provide the quality of life for our citizens. And we also need to redesign our aging infrastructure. And we need to do that with this carbon in mind. But, and here's the challenge, this is another layer of complexity. Whilst we're doing that, we've got to deal with the implications of current climate change. In other words, we've got to be resilient. Our infrastructure is going to be designed for 100, 120 years or more. So we've got to get it low carbon, maximize its efficiency, and be able to be resilient to the changes, because we're already seeing these changes. So we need to be mindful of that. So hopefully what I've done is given you a very brief overview, a little bit of where the science is, where the carbon is in infrastructure, and some conclusions about where the challenge is. And that leads us nicely on to the two remaining lectures in this session. The first one is going to be around the roadmap for Sweden. What does that look like? What's the opportunities there? And second, then we're going to have an international perspective coming from the UK.